In this video lecture, let us see the basic operational concepts of a processor. So to perform a given task, the program may be consisting of some n number of instructions which is stored in the memory has to be brought from the memory to the processor. Only then it will be executing the particular operation. So let us see how the instruction is being fetched and how it is being brought to the processor and what are all the registers involved in execution of the specified operation. So let us see some example instructions, assembly language instructions. Maybe add LOC A means some location, memory location A, comma or not is a register. So you're going to add the contents of the memory location and the register or 0. Load means loading the data from maybe a register to the memory location. Then adding the contents of R0 and R1. So this is an example. So you're loading the data from a register R1 to a location, memory location. Again, you're transferring the data from R0 to another location. Then add R0 and R1. These are all some of the sample instructions. So these are all some of the registers involved in the instruction execution. So let us see what are all the registers. You have MAR. MAR means memory address register and MDR is memory data register and PC is program counter and IR is instruction register. Apart from this, you will be having n number of general purpose register from R0 to Rn. So this can be used for your program execution for storing the data, maybe the intermediate results as well. So when I say IR, instruction register, so this will be holding the instruction which is currently being executed. Whereas PC, that is program counter, will be having the memory address of the next instruction that has to be fetched and executed. So IR will have the currently executing instruction and PC will have the address of the next instruction to be fetched. And MAR will have the address of the location that has to be accessed and MDR will have the data which has to be read or which has to be written. Apart from this, you have interrupts and interrupt service routines. These are all some of the terminologies used with respect to the operational concepts. So as I told you, IR is going to have the instruction that is being executed. And program counter is going to have the address of the next instruction to be fetched. And once the data is moved to the instruction register, this program counter will be incremented to point to the next instruction. And MAR will be holding the address of the memory location from which the data has to be transferred. And MDR will have the data to be written or the data to be read from the particular memory location. As I told you, this general purpose registers are also referred as scratch pad registers. So this will be used for holding the data or maybe the intermediate results of the execution. So when it comes to an instruction execution, there are two phases. One is fetch and the other one is execution. So when it comes to an instruction fetch, so the execution will start by setting the PC to point to the first instruction. So initially the program counter will be pointing to the first instruction and the contents of your PC will be transferred to MAR and followed by a read signal. So only after receiving the read control signal, so the processor will understand that it has to read the data from the PC. And then it will be transferred to MDR. And then from MDR, the contents will be transferred to IR, followed by instruction decoding. So all these steps comes into the category instruction fetch. And after the instruction is being fetched, then we have to fetch the data or the operands. So from the general purpose registers, the data has to be fetched and will be transferred to ALU. ALU will be performing the arithmetic operation, and then the results will be stored in the temporary register. So this is how an instruction is being executed in the processor.